To solve radical equations, first you have to be given one. So let's say we have a radical equation, square root of r minus 2 equal to 3, and we're trying to solve it. Well, the first thing you want to do, in order to get rid of a square root, you have to square it. So you would square this side, and whatever you do to one side of the equation, you have to do to the other, so you would square that side. When you square a square root, all it does is gets rid of the square root, so you end up having r minus 2. And then you have 3 squared, which will give you 9. And so to solve this, you add 2 to both sides, and you end up with r is equal to 11. So let's say another one. Let's say you have the square root of 3k plus 1, and then minus 4 equal to 0. First thing you want to do is you want to isolate the square root to get it by itself. So what we're going to do is we're going to add 4 to both sides. Move the 4 to the other side of the equation. And so we have the square root of 3k plus 1 equal to positive 4. And so now that the square root's all alone on one side of the equation, we can square both sides. And we end up with 3k plus 1 on the left side equal to 16 on the right. Because when you square a square root, all you do is get rid of the square root. And 4 to the second power will give you 16. So to solve it, you subtract 1 from both sides, and you end up with 3k is equal to 15. And then you divide both sides by 3 to get k isolated, and you end up with k is equal to 5. Let's say you were given 2 square root of x, and that was equal to the square root of 3x plus 4. Well, since you have square root on both sides, they're both isolated, so you would square both sides, and that will get rid of the square root. So you'll end up having, when you square 2, you'll get 4, and when you square the square root of x, you'll just get x. So the left side would be 4x. The right side, the square gets rid of the square root, so you end up with a 3x plus 4. And then when you solve it, you subtract 3x from both sides, and that ends up giving you an x equal to 4. Okay, let's say you have the square root of k squared plus 2k plus 9, and that's all equal to k plus 3. Well, the square root is isolated on the left side, so to get rid of it, you would square it, and you have to do the same thing to the other side. So on the left side, you end up with k squared plus 2k plus 9. On the right side, that really looks like a k plus 3 times another k plus 3. That's what k plus 3 squared means. So you have to pretty much simplify the right side. So we have k times k, which will give us k squared, then k times 3, which will give us a 3k, and then we take this 3 times k, which gives us another 3k, and then 3 times 3, which gives us a 9. So the left side is still k squared plus 2k plus 9 on the left side, so I'll just rewrite it here. And on the right side, these are like terms, so we end up having k squared plus 6k plus 9. And so solving it, we'll subtract k squared from both sides, and the k squares will go away, and we'll end up with 2k plus 9 is equal to 6k plus 9. We'll subtract 9 from both sides, and they'll go away, and you end up with 2k is equal to 6k. The k's have to all be on one side, so we're going to subtract the 2k from both sides, and we'll end up with 0 is equal to 4k. So to solve for this, to get k isolated, we divide by 4, and we end up having 0 is equal to k. Let's say we have the cube root of 2x plus 5, and that equals the cube root of 6x plus 1. So to get rid of a cube root, you would simply cube both sides, which raise them to the third power. So you end up with 2x plus 5 equal to 6x plus 1. and then you just solve it from here. So you subtract 2x from both sides, and you'll end up with 5 is equal to 4x plus 1. Subtract 1 from both sides, you got 4x is equal to 4, and then you divide both sides by 4. So what you end up with is x is equal to 1. So even though they raise the power to the third, that doesn't mean that the problem is harder. So let's say that you have fourth root. So let's say we have the fourth root of x plus 8, and that's equal to the fourth root of 2x. To get rid of a fourth root, you just raise it to the fourth power, and that'll just give us x plus 8 on the left, and that'll give us a 2x on the right. So to solve this, we just subtract x from both sides, and we end up with 8 is equal to x. Let's say we have the square root of 3p plus 4 minus the square root of 2p minus 4 equal to 2. Well, you know, in order to solve a square root equation, you have to isolate one of the square roots at least. So let's add a square root of 2p plus 4 to both sides. 2p minus 4 to both sides. So that would get rid of it over here, and you'll have square root of 3p plus 4 equal to 2 plus the square root of 2p minus 4. So to solve it, you would square both sides of the equal sign. So the left side is just going to give us a 3p plus 4. The right side, what you're going to have, what it really looks like, I'll put it over here in the corner, is a 2 plus square root of 2p minus 4 times another 2 plus square root of 2p minus 4. So we got to do the double bunny hop. 2 times 2, that will give us 4. Then 2 times the square root of 2p minus 4 will give us 2 times the square root of 2p minus 4. Okay, and then the square root of 2p minus 4 times 2 will give us 2 times the square root of 2p minus 4. And then we take the square root of 2p minus 4 times the square root of 2p minus 4. Since you're multiplying the same thing, you're really squaring it. And when you square a square root, you get what's under it. So you end up with a 2p minus 4. So on the left side, it's still 3p plus 4. On the right side, the 4 and the 4's will cancel out. You got a positive 4 and a negative 4. These two will give you 4 square root of 2p minus 4. And then plus 2p. So we still have a square root in the problem, which we can't have, so we have to isolate it. So what we're going to do is subtract 2p from both sides. And we end up with a p plus 4 equal to 4 times the square root of 2p minus 4. So to get rid of this, you have to square both sides. When you square the right side, you end up with a 16 times 2p minus 4, because 4 to the second power is 16, and the square root of 2p minus 4 squared is just 2p minus 4. On this side, you have to do the double bunny hop again, which is p plus 4 times another p plus 4. And when you do all of the pieces, you'll end up with a p squared plus 8p plus 16. So it's going to be p squared plus 8p plus 16 on that side. So let's rewrite it. P squared plus 8p plus 16, and that's going to equal 32p minus 64. And we're solving this equation. If we have a square in there, we want to get everything equal to 0. So we're going to have to subtract 32p and add 64 to both sides. So subtract 32p, add 64. So what that's going to give us, bring it over here, that's going to give us a p squared minus 24p plus 80 equal to 0. This is a quadratic, and since you don't have anything in front of the p squared, you can do the PQ method, which says what two numbers multiply to give you positive 80 and add to give you a negative 24. So those two numbers are 20 and 4. Since the number they multiply to give you something positive and add to give you something negative, that means that they're both negative. So your two numbers are negative 4 and negative 20 equal to 0. Then the question you want to ask yourself is, what does p have to be in this parenthesis to be minus 4 to give you 0? P has to be positive 4. And what does p have to be in this parenthesis to be minus 20 to give you 0? P has to be a positive 20. So your two solutions are when p is 4 and p is positive 20.